Hey, Dr. Mike here. One molecule, energy, aging, everything. We're talking NAD plus with Dr. Charles Brenner.
You're listening to Live Foreverish, a show dedicated to helping you live just a little longer. Here's your hosts, Dr. Mike and Dr. Crystal Gossard.
All right, welcome to Live Foreverish. Dr. Crystal, I'm very excited to have an expert on to talk about NAD plus because you and I have been talking about this a long time.
I know. And when we say an expert, we're talking someone, at the ground level, at the forefront of one of the NAD precursors in R. So we'll be talking about nicotinamide riboside and how that can feed into the NAD system. So I'm really happy to have him on.
His name is Dr. Charles Brenner. He's the Alfred E. Mann Family Foundation Chair in Diabetes and Cancer Metabolism at City of Hope and Chief Scientific Advisor at Niagen Bioscience. Dr. Brenner is the leading global scholar on the topic of synthesis, regulation, and quantification of NAD coenzymes and NAD metabolites in health and disease. Dr. Brenner, welcome to Live Foreverish.
Thanks. Pleasure to be with you.
Now, here's the toughest questions you've ever faced. Are you ready, Dr. Brenner?
I'm the OG NAD guy. That's the short introduction.
There you go. Yes. So you'll love this question, but we got to set it up for the audience. Give us your nice, simple definition of what NAD plus is and why is it so essential for us?
It's the central catalyst of metabolism. Essentially what NAD coenzymes do, and there's really 4 of them. You called out NAD+, but there's NAD+, NADH, NADP+, and NADPH. And what they do is they carry electrons that make life possible. So in food oxidation, right, in breaking down protein, fat, and carbohydrate, to produce biological energy in the form of ATP. NAD coenzymes carry high energy electrons that feed into the mitochondrial electron transport chain in order to generate ATP. And then in synthesis of biological molecules, like our cells have to make their own DNA, RNA, protein, fat, etc. NAD coenzymes transfer high energy electrons for all of those processes. And then things don't last forever, right? So their molecules get damaged, DNA gets damaged famously, and NAD participates in the repair process of macromolecules as well. So it's the central catalyst of metabolism.
And I listened to a podcast that you recorded, maybe a couple of them in the past. And I like the analogy. I think you gave an analogy at one point of the car and the fuel in the car, and that car has to, combust. Wiring. It was the wiring in the car.
It's not the fuel, it's the wiring, right?
The wiring in the car that's really handling and transferring that energy.
Correct.
Those electrons so that the car can run. And I think that's a nice analogy for our viewers. And the whole point here is, we do a lot of things to try to maximize our health. And one of those components is to try to eat the right foods, and you have your carbs, your proteins, and your fat, right? So that's the fuel.
That's protein, fat, and carbohydrate. That's the fuel.
Right. And so can you take us from that carb, protein, fat, and then how that gets into the cell and how we release the energy from the fuel and just kind of put it all together in that picture?
So what is metabolism?
I just want to start a little bit ahead of the where you started.
Okay. So let me introduce the analogy to reinforce the question. So everybody, you may be driving an electric car right now as you listen to the podcast, or you may be, waiting for your toast in your toaster oven. Whatever device you can think of, electrical device that you can think of, it runs on high energy electrons, right? So your toaster is plugged into a wall outlet where you have central power coming in, or maybe you're living off grid and you have solar energy that's going into a battery that's going into the toaster. There's high energy electrons that are running the toaster. And in your car, there's a big battery and there's wiring, again, that is going between the big battery and all of the things that require power. The wipers, the front wheel drive, the back wheel drive, the heat, the radio, et cetera, et cetera. So the fuel, for solar energy is the sun. The fuel for coal-powered energy is coal burning. And the fuel for human beings is the stuff that we eat. And the stuff that has calories is the fuel. It's protein, fat, and carbohydrate. Now, NAD forms the wiring that carries high energy electrons from our fuel to all of the fuel requiring processes. So literally NAD plus picks up high energy electrons from the oxidation of protein, fat, and carbohydrate, forming NADH. NADH transmits the high energy electrons without, it's like lossless transfer of music, where you're trying to transmit something that has a lot of energy to it. So NAD plus captures a high energy electron, it forming NADH. NADH releases high energy electrons at the top of the mitochondrial electron transfer chain in order to generate ATP. And then there's a very important additional pair of coenzymes called NADP and NADPH. Our bodies make NADP, and then we're going to get to precursors really soon, as you can imagine. Our bodies make NADP from NAD+. NADP captures high energy electrons to form NADPH, and then NADPH doesn't put the electrons in to make ATP. It puts electrons in order to make DNA, in order to make lipids. So it transfers high energy electrons to make stuff.
Yeah, to build.
Because we have to make all
body.
of our own lipids, right? And one of the things that people have noticed, one of the first things that people notice, if they take if they take NR, they take Niagen, which is in your products, is it doesn't feel like a cup of coffee, right? They ate their food, their satiety is their satiety, so they get filled up from the things that have macronutrients, the things that have calories. And but what they notice in the first 2 or 3 weeks is that their fingernails are growing faster. Their hair, cutter tells them it seems like your hair is growing faster. That's an anabolic component to the NAD system. So that's the NADPH piece of this. The NADPH piece of this is it's providing electrons for biosynthetic reactions, probably supporting muscle growth, although that's not proven. It's almost certainly supporting workout recovery. That's polyanecdotal kind of thing. The thing that's really proven clinically, and I think 8 randomized clinical trials, is that by boosting your NAD system, you can lower systemic inflammation, right? And so the idea that this is a way to age better because the NAD system, controls the over response to inflammatory stimuli, and that's been demonstrated clinically.
Okay. Well, if I have to boost my NAD system, that implies I'm losing it as I age. Well, why does that happen?
So it's not entirely clear, believe it or not. And in some ways it's stated more confidently than it should be from my point of view. I'm a stickler for evidence, right? And so I don't go out and say things that we can't prove. But we know of about a dozen ways in which normal things that we can encounter in life attack the NAD system. So, and I'm not sure whether time is one of them, or these are all things that happen over the course of time. But, we all enjoy sunlight. We all need oxygen, yet sunlight and oxygen both disturb the NAD system in distinct ways.
Mm-hmm.
So sunlight, by having ultraviolet rays in the solar spectrum, damages DNA, right? And then there's a process that's mediated by enzymes called PARP, poly-ADP ribose polymerase. PARP gets activated when it sees DNA damage, and it churns NAD in order to repair the DNA. When we have oxygen-dependent processes, which is actually intrinsic to making ATP, right? As you both know,
right?
An MD and a Ph.D. You both know. You both took the same biochemistry class, and you learned that oxygen is the ultimate electron acceptor. NADH is the first electron donor, right, in that electron transport chain. And then for extra credit, we could name a bunch of the intermediary acceptors, iron sulfur clusters, coenzyme Q, cytochrome oxidase, blah, blah, blah. And then ultimately, electrons go on to molecular oxygen forming H2O, right? So oxygen is required in ATP production. And whereas the electron transport chain, as we diagram it, produces H2O, it also produces a little bit of superoxide and hydrogen peroxide and stuff like that, right? So those are reactive oxygen species. And detoxification of reactive oxygen species can also deplete the NAD system.
Okay.
Time zone disruption can disturb the NAD system. It's been known for a very long time that drinking alcohol disturbs the NAD system in the liver. That's actually proven now clinically in the human liver samples by my group in collaboration with a group at University of Birmingham. Overnutrition, so getting fat and diabetic, disturbs the NAD system in a mouse's liver. We think that is also true in humans. Infection and inflammation disturb the NAD system. COVID infection activates 5 different members of the PARP superfamily that disturb NAD. So living life, is a challenge to the NAD system. Is basically what we found.
Yeah, it kind of sounds like being alive. It kind of takes a hit. NAD takes a hit from that.
The beauty of life, right, is that we get to experience all of the things, and in a life with no stresses or stimuli, that'd be a pretty boring life, right?
Yeah.
Where and I sometimes when I get people together, I say, okay, imagine we're going to do a giveaway, prize here. And the winner is going to be flown on a jet to Ibiza, if I pronounced that correctly, Ibiza. And you're going to be on a beach, right, in Ibiza. And there's going to be wonderful loud music and beautiful Spanish sun and red wine and lots of food. And so now you have time zone disruption, right? You have sunlight, you have oxygen, you have lots of food, you have alcohol. All of those things disturb the NAD system. Now, I'm not saying like music disturbs the NAD system, but we know that noise sufficient to produce hearing loss attacks the NAD system.
Yeah.
And that nicotinamide riboside can protect against that, hashtag in mice. And so, living life with all of its stimuli and exposure to other people, many of whom might have the flu or, COVID, that can disturb the NAD system. So,
Well,
your NAD system.
I'm gonna take that trip, especially if it's free, just so you know.
Yeah.
NAD depletion or not.
Right. And so, we have already talked a little about inflammation. When you exercise, and if you measure IL-6, IL-6 is an inflammatory marker that goes up when you exercise. Well, it's trying to, heal you, right? But the persistent inflammation, can start wearing down your joints and stuff like this. And so the effect of NR is to kind of help you manage inflammatory stimuli and allow all of the processes that allow you to convert your fuel into energy, make all your macromolecules and repair all your macromolecules.
So I think that's a good segue into, let's talk about NR. We can talk about precursors in general. I know we want to focus on NR, but in your opinion, is that going to be kind of the top strategy to support NAD? And tell us about NR, what it is.
Yeah.
Maybe give us more details about niacin in general and all of those precursors.
Totally. So what we described for NAD coenzymes, which are the inside all of our cells, and I literally mean all of our cells, every single cell type, not only in a human, but also in every bacteria in our microbiome, every fungal organism on the planet, every plant, NAD coenzymes are the central catalyst of metabolism. Okay. Now, NAD and NADH have two phosphate groups on them. NADP and NADPH have three phosphate groups on them. And compounds with phosphates have to be made inside of cells. Compounds with phosphates don't cross the membrane. This has been known since 1980. There was actually a Nobel Prize given for it to Gertrude Elion and George Hitchings years and years ago. And so this is well known. And just in the same way that skin cells make their own collagen, right? You can't rub a cowhide on your skin and expect to improve your skin's collagen, right? But there's a gazillion products that will take collagen, right? Break it down into peptides, right? And then you can put those the collagen peptides, look on your shampoo bottle, right? It's there. Look in supplements, it's there, right? And so people are ingesting or applying peptides from collagen, and it goes into cells, and then they make their own collagen, right? So same thing with NAD precursors, is that NAD is in food, right? I just said that it's a central catalyst of metabolism in plants and animals. So if you're eating, animal, and plant stuff, which we all are in our diet, you're getting NAD coenzymes, but the NAD coenzymes break down, right? And the biggest piece of NAD that can get into cells is nicotinamide riboside, NR. And so the NAD breaks down if you sort of break it in half, you have an NMN piece and an AMP piece. Both of those break down further into adenosine and NR. NR can further degrade into nicotinamide and nicotinic acid. And then those are what we call the 3 vitamin precursors of NAD: NR, nicotinamide, nicotinic acid. They all have a biosynthetic pathway. Nicotinamide and NR can be made into NAD in essentially every single cell that we know of. Nicotinic acid can be made into NAD in a lot of cells, but not all, probably not neurons.
Oh, okay.
Yeah. And so there's differences. And then there's also like differences in other properties of these things. So like high dose niacin, high dose nicotinic acid gives you a flushing response, right? And so in the older days, before statins and so forth, there were more people that took high dose niacin to control their blood lipids.
Right.
And
some people still do.
And some people still do, right? And they kind of have to get used to the flush reaction. And so NR and nicotinamide don't give a flush reaction. That's one of the ways that we know that they have unique properties and unique biosynthetic pathways. And so there's at least 8 clinical trials, randomized clinical trials, showing that nicotinamide riboside lowers inflammation. I don't think there's any clinical trials, despite decades of experience with nicotinic acid and nicotinamide, showing that they lower inflammation. And there's a very exciting randomized clinical trial that was done showing that for people with peripheral artery disease, that people taking NR had an improvement in walking speed. And in the placebo arm, they had, in a 6-month trial, their walking speed was worse, right? And in a because I mean, this is a serious disease of aging, right? And the mostly former smokers and so forth and so on. And so they were not only able to preserve their walking speed, they were able to improve their walking speed, which is going to be a feed-forward result, right? Because if you improve your exercise tolerance, right, a lot of things are going to start getting better. So head-to-head trials are very few, but on the basis of what we know about the biosynthetic pathways, we think that NR is the most efficient way to restore and boost NAD in humans.
Well, why can't I'm going to back way up for a sec, because I think some listeners have this question. So all of this information about the precursors is great. It's great to hear about NR. It does in every cell, you said, right, can increase NAD. So that's the goal here. But why can't I just take NAD in a supplement? Why do I need a precursor?
Yeah, so basically it's going to be inefficient because it's going to break down to NR, nicotinamide, and nicotinic acid. So intracellularly, the goal is increasing NAD and NAD coenzymes. But if we accept the premise that your NAD system, comes under attack in these inflammatory conditions and in the course of aging, and that you need something to efficiently restore and boost NAD, nicotinamide riboside is going to outperform NAD itself. NAD has most of its molecular weight is not going to contribute to intracellular NAD boosting because NAD is going to break down into the adenosine moiety, the phosphates, and the NR.
So just to go back to something else that you mentioned with having those phosphates and then they can't enter into the cell. So is that one reason, or is it also absorption issues with taking NAD directly?
In technical parlance, it's called ADME, which is absorption, distribution, metabolism, and excretion. And, in order to metabolize and make available precursors, NAD basically has to be digested. And then, more of the NAD precursor pool is going to basically, end up, excreted essentially if you were to take NAD itself. Yeah.
Okay.
Well, let's move. Okay, so we got the NR idea, and that's going to be the best way to boost intracellular NAD. Let's talk about Niagen NR, right? Can you share a little bit more about this specific formulation of NR and the company behind it?
Yeah, right. So
can you also talk about dosing as you answer that question?
So you're a company where you have consumers, right? You want to make products and you want your products to be safe and evidence-based and supported by safety testing and clinical testing for safety and efficacy, right? And so, the company that licensed the original NAD boosting technology from Dartmouth, which was my IP, and then various people's synthesis protocols to make nicotinamide riboside chloride. That company used to be called Chromadex. It's now called Niagen. They named the safety tested formulation of nicotinamide riboside chloride Niagen. That's the trade name. And it's the source of the vast majority of the NR that goes into clinical trials around the world. Right. So if a consumer is going to be parting with hard-earned money in order to buy a supplement and have an expectation of the safety and efficacy of what is in the bottle, you're helping your consumers do that because you're sourcing your nicotinamide riboside chloride from Niagen, which is the company that put that material through the safety testing and provided it with external colleagues to do the clinical testing, right? And somebody else that makes a different product, which is a different salt form, doesn't have as much data behind them in terms of what is the safety, what is it contaminated with potentially, how do they do their manufacturing, how do they assure their quality, and that, a gram is a gram. And so, Niagen is the most established company in the business. They have the most patents, the most technology, the most safety testing, the most efficacy testing. And the company is also conservative with respect to the claims. Like though, hey, it's 2026, folks, and we now know that literally the same research group tested metformin, for peripheral artery disease, and it failed, and tested nicotinamide riboside in peripheral artery disease against placebo, and it succeeded, right? And we have people around the world that say that metformin is an anti-aging drug, and we can show clinical data showing that nicotinamide riboside improves walking speed in a real disease of aging, yet we don't run around saying, oh, this is going to make you live longer. Why?
Yeah.
Because you can't make that claim. You can't, there's no clinical trial that would allow you to make that claim. So this is a very evidence-based, company where it's sort of like, under promise and over deliver is the goal.
Yeah.
So that's why Niagen, is that it's the most it's the safest and most evidence-based source of.
Yeah. I mean, as Dr. Brenner, as a clinician, I want to use the form that has shown efficacy in clinical trials. I mean, at the end of the day, it's in safety and efficacy, right? I mean, that's what Niagen RN does for us. What about dosing, as Dr. Crystal was asking about?
Yeah. So initially, from the very first clinical experience that we had, which was sort of like, let's look at 100 milligrams, 300 milligrams, and a gram, essentially no adverse events. And it's kind of dose-dependent increases in NAD. So 300 milligrams became the initial consumer dose. And then as more people started doing randomized clinical trials looking for, efficacy in something, the results started appearing at kind of a gram, right? Even 1 to 2 grams per day. That's where you're seeing 8 clinical trials showing lowering inflammatory markers, extending walking distance or walking speed in peripheral artery disease and so forth. So, so 300 milligrams is sort of the entry dose, and then there are lots of people that are at 500 milligrams or a gram a day.
Well, do we know what percent increase of NAD we need inside the cell to produce the clinical results that you're seeing? I mean, is it 40%, 50%?
So the cell is a problematic concept, right? Because we're gonna draw blood, right, as we follow safety and the most easily monitored biomarker of NR supplementation, we're gonna look at blood.
Yeah.
But is the deficiency really in a tissue NAD, and is that tissue accessible in the clinical trial? Well, no one's donating their brains in a, mild cognitive impairment study, right? And in the first RCT where we saw the anti-inflammatory effect, we did actually have muscle biopsies, and we were able to see an effect on skeletal muscle NAD metabolism. But I think I'm giving you a kind of a complex technical answer, but in most of these trials, you see very substantive increases in blood NAD, like 50% increase, 90% increase, 100% increase in blood NAD. But what might be more important is that there's a 20 or 25% deficit in the kidney that's going from a 25% deficit to no deficit, right? But we're not monitoring that tissue.
Yeah, I guess
in the future, I think we're going to need to have imaging and more sophisticated technologies.
Yeah. But for now, clinically speaking, again, if I know a gram of NR produces anti-inflammatory results, which then has subsequent downstream effects, clinically speaking, I can act on that.
Right?
Yeah.
That said, I don't think that there's a use case for, and let me give my disclosures now. Okay. So so my, Dartmouth IP was licensed by Chromadex. Company became Niagen. I'm their chief scientific advisor. I'm also the chief advisor of NADMed, which is a company based in Helsinki, Finland, that has a testing, method. And largely the testing method is provided for clinical trialists and researchers that are analyzing, this exact question that Dr. Mike is asking. Like, at a particular dose, what was the blood response, and how does that correlate with the clinically interesting questions, like the walking speed, the anti-inflammation, the cognitive measures, or whatever they're measuring. That said, even though I advise a company that is selling an NAD testing kit, I do not think there's a consumer use case for that right now. Because if you take an NR supplement, your NAD is going to be up. Literally in 8 hours, your NAD, it's like, if you take vitamin C, do you need to then take a vitamin C testing kit? No, you don't. So
well, somebody might push that on us. I don't know.
Some people try.
Some people try, but I think actually, if you want to know my real feelings about it, is that some of the what I'm going to call the age testing, field, is that I feel like the age testing and arguably NAD testing today in 2026 is a research tool, and the marketing to what I call the worried well is not really helpful, because all it does is it gives this false sense that you can optimize everything and that every measurement is meaningful, which I don't think that every measurement is meaningful. I think how you feel is really meaningful, and your walking speed and your ability to have the energy and joy to make out with your partner is meaningful. But I think that your exact, beta clotho level or something like that is not meaningful.
Having every measurement sounds great, but I can tell you right now that would only cause more questions. I think it's a significant answer.
So, Dr. Brenner, I think that what you're pointing out, that there are some knowns and many unknowns.
Yes.
And what I would like to hear is, can you just kind of give us those buckets? So what are the things that we know for sure? Like, we know if you take NR, we have seen blood levels of NAD increase. So we know that.
And that's accompanied by lower systemic inflammation.
Right. So that's the other piece. So what are the knowns from clinical research? So we have the inflammation, the peripheral artery disease.
Right.
Can you give us kind of the buckets of the clinical studies?
Yeah.
These are what we know. And this is what we're seeing in preclinical and very promising. And we're hoping to see more in the future.
Yeah. So I would say anti-inflammation in humans is well established. Peripheral artery disease is super exciting. COVID time to recovery, maybe. So there's a phase 2/3 study that was done it was a collaboration between investigators in Sweden and Turkey. And it came after our December 2020 paper, where we showed that coronaviruses, literally all coronaviruses as far as we can tell, so COVID-19 as well as others, disturb the NAD system. And my thought in 2020 is that we should do a prevention trial with NR. And what I wanted to do was I wanted to take the household members of, let's say, medical personnel and delivery drivers, right?
Still
Who are
working.
out in the world in 2020, 2021, going out of home and working every day. And where their partners, let's say not yet vaccinated, had a higher risk of infection than people in fully sequestered households, right?
Yep.
And I wanted to see whether we could prevent infection with nicotinamide riboside, right? There was a window in time to do that study. That window's passed.
Yeah.
So we didn't get to do that study. But what people did is they tested whether NR, initially the Turks and Swedes, in combination with 3 other over-the-counter molecules, would accelerate time to recovery from COVID. And they got a positive response, a very strong positive response. They didn't test NR as a monotherapy, as a single supplement.
That's a limitation there because it wasn't by itself. Yeah.
Now, more recently, there's a group from Massachusetts General Hospital that looked at long COVID. And again, some of the first NR trials, and if you're in the vitamin space, you have this exact problem, a lot of time, which is that the early studies are underpowered. Like you'd love to see 500 people in each arm, right? You might only have 20, right? And so there's a suggestion from a long COVID study that was placebo controlled that people within group, in the NR group, had better executive function, sleep, and less depression, and higher perceived energy, which is a big deal in long COVID, if they were on the NR arm. This was not reported in the placebo arm. So beginning
and what dose was
end
that?
of trial, right?
Do you remember the dose?
1 gram per day. Yeah. So that's a positive enough result that, it's going to
It's a maybe.
stimulate a
I like
larger
that
trial,
in
right?
the maybe.
I mean, when you think about it, though, in the context of long COVID, we know there's inflammatory dysregulation involved. And so, and you've already established NR and NAD in helping balance and reduce them. So definitely more research, right? I mean, that would be
absolutely.
It makes sense to spend some money there.
Fully justified, right? The rationale is there, right? Some of the early trials, give me like a side headache when I think about them. Okay, because it was too much wishful thinking, right? So on the other hand, when you do an early phase trial and you have secondary endpoints, you can learn things from what you learn from the secondary endpoints. So I'm going to give you 2 examples of trials that I wish they could have been designed differently in, let's say 2017, 2018, when the trials are being designed, but what we learned from them, right? So one of the early trials, I have already alluded to it a little bit, was done at University of Birmingham. And they said, well, what's more important than skeletal muscle for healthy aging, right? We need our skeletal muscle, right, in order to dispose of glucose and to not fall and to just live life, right? And so they take older men, they do a crossover design, placebo-controlled trial with 1 gram of nicotinamide riboside, and their primary endpoint is grip strength in 3 weeks. Well, you're both cringing because you're not going to get improve grip strength unless you exercise your muscles, right? You exercise your muscles, you're going to have better grip strength. You could look at the potential additive effect of NR in people that do a standard of care way to improve their grip strength, but it's not going to be magic, right? It's not going to magically make people stronger, right? And so it was in that study, it was like a top line failure in that there's no change in grip strength in 3 weeks. But that was a study where when they analyzed the blood, they said the people that took NR had strikingly lower inflammatory markers circulating.
Yeah. So you can tease that out of it, right?
And in fact, it was such a strong effect. Do you know what in a crossover trial means? That half of the people started on NR, then they went on to placebo. Right. They didn't know. And then half of the people started on placebo, and then they switched over to NR. So the effect on the anti-inflammatory thing was so strong that if they took the NR first and then went on placebo, when they finished with the placebo, their inflammatory markers were still lower than before they started. So the 3 weeks of washout was not enough. They still had a benefit of that.
That's the power of crossover studies, right? That makes it really cool. Yeah.
It was cool. But then the other thing that that frustrates me a little is that people that don't read the literature and they can't tell the difference between the disease course in a mouse versus a disease course in a human being, right? So in a mouse, we can induce overweight and type 2 diabetes in a couple of months, but we can treat it in a month or two, right? In 70-year-old Danish men who are overweight and insulin insensitive and diabetic, their overweight and type 2 diabetes developed over decades, right? Of declining physical activity. They haven't played hockey in 4 or 5 decades, right? Their pack years of smoking have gone up. Their cumulative exposure to alcohol has gone up. We're talking decades, right? So you don't do a clinical trial and expect to have weight loss and insulin sensitization in 13 weeks, right? You even with GLP-1, you need 26 weeks. And the mechanism for GLP-1 is that it lowers food intake. The most important mechanism. And, NR doesn't lower food intake. So you can't expect that result in 13 weeks, right? So again, that was a top line failure that NR supplementation didn't lower weight in 7-year-old type 2 diabetic Danish men. However, in that trial, when you looked at the fatty liver, the 6 people in the trial that had the highest fatty liver had striking improvements in their liver fat if they were NR supplemented. If they were NR supplemented. So this is a trial we'd like to see done. It should be longer. It should be randomized on the basis of their fatty liver rather than being an incidental thing that is very variable in the population, right? I'd love to see wound healing done.
Oh, okay. Yeah. Well, Dr. Brenner, we could go on and on and on talking to you right now. This has been all fascinating, but we're going to wrap up here. And I'd like your just quick summary or the last thing you'd like to say to the listening audience about NR, NAD. What would you like to say?
There's one other thing. It's a little bit techie nerd, oriented, but I feel like your listeners may be sophisticated enough to to address this. There's a lot in the literature that has been appearing about the microbiome and saying that NR is fully dissembled in the liver or the intestine, and all it does is circulate nicotinamide and nicotinic acid. We know that's not true because in humans, high-dose nicotinic acid causes flushing, and high-dose nicotinamide riboside doesn't cause flushing.
Right.
We also know that, genetics doesn't lie. And when you knock out the nicotinamide pathway in skeletal muscle and in heart, oral NR addresses the problem in the muscle and the heart. So we know that oral nicotinamide riboside has systemic benefits, which is proven, clinically in 8 randomized studies on, anti-inflammation and in improving, human function in peripheral artery disease. So I think that people are going to continue to see a lot of exciting things about the, beneficial effects in humans of nicotinamide riboside. And I think it's important that, people consider the source when you look at the kind of clinical claims that are being made. And if the groups tend to be conservative and they underpromise and overdeliver, it's much more credible than people making, wild, claims of, anti-aging, which are kind of run rampant in the industry.
So you've been listening to Dr. Charles Brenner, the Alfred E. Mann Family Foundation Chair in Diabetes and Cancer Metabolism at City of Hope and Chief Scientific Advisor at Niagen Bioscience. Dr. Brenner, how could our audience connect with you?
They can find my lab website at brennerlab.net. They can ask me questions on Twitter X at Charles M. Brenner. I think Instagram as well. Thanks very much.
Thanks for coming on today. This has been fascinating. I think we're going to have you back on.
Pleasure.
As more science stuff comes out. So
yeah,
we'll be in talk with you for a future show. And thank you for listening. Don't forget, you go to liveforeverish.com where we have tons of other shows that you can download, like, share, respond, and now review. That would be fantastic. We really appreciate that. And of course, subscribe so you never miss a show. And our sponsor, Life Extension, wants to say thank you with a discount code. Go to lifeextension.com and use the discount code podcast. And you will get 10% off $50 or more plus free shipping and handling. I'm Dr. Mike. Dr. Crystal.
I'm Dr. Crystal.
Here she is. Thanks for listening.